Hello guys, logic gates are the building blocks of a digital system. It's an important part in the semiconductors chapter, and in almost all the competitive exams at least one question was asked regarding logic gates. So logic gates, as we know, are the building blocks of a digital system, and they can have how many other inputs possible, but they have only one output. There is something known as truth table. Truth table is where you can fill your inputs and predict your output. Okay, so that's called the truth table. There are three basic logic gates. First is not, second is or, third is and. Okay, not means it's like opposite. For example, if my input is 1, the output will be 0. If my input is 0, the output is 1. So that's called not. Or means A plus B. For or, you need 2 inputs. Okay, you should draw it like this. It's a bit sharp at the end. Okay, this is or. It's if I'm going to put 1 plus 1 is 1. So this is or. And means A dot B. This looks like a semicircle. Don't get confused between or and. In or there is a sharp edge, and in and there's like a semicircle, very curved and smooth surface. That is and. Okay, if I'm going to put input as 1 and 0 here, so the answer will be 0. That's called and. These three are the basic gates. Now we will see 2 more additional gates, which is known as NAND. NAND means not plus and. That means this gate plus this gate. It looks like a bulb type. One small circle will be there. Okay? That means it's not plus and, which is NAND. It's quite simple. A dot B, you're going to put, see, 1 0 1 dot 0 is 0. Now you're going to put opposite. We know not means it's quite opposite, so this dash means opposite, which is 1. And last one, which is NOR. You must have guessed, not plus or. This one plus one small bulb, that is known as NOR. A plus B dash, that means 1 0 1 plus 0, which is 1 dash equals to 0. So these 5 gates are very important, and you can do a lot of questions only with this 5 gates using a truth table, or you can also use some Boolean expressions, which I'm going to say it now. So I'll be writing some formulas which are very important, you should memorize. First is A plus A is equal to A. A dot A equal to A. A plus A dash equals to 1. A dot A dash equals to 0. 1 plus A equals to 1. 1 dot A equals to A. 0 plus A equals to A. 0 dot A equals to 0. I'll be giving you 2 more most important one, which is known as De Morgan's law, which is A dash plus B dash equals to A dot B the whole dash. Okay, this is known as De Morgan law, which is very important in solving questions. If you know to use this, you can solve the questions easily rather than drawing the truth table. A dash dot B dash equals to A plus B whole dash. So this is an important thing which you have to memorize. Okay guys, let's solve some question. Which type of gate is this? First we will try to using the formulas we have seen. Okay, first this is NOT gate. If you see, it is like this. It's a NOT gate. Both A and B are NOT gate. So A dash B dash. So this is the first step. This is the input. A dash is the input, B dash is the input. Now this looks like, I said you, this looks like the sharp end with a bulb. That means it's a NOR gate. That means A dash B dash. OR is what? OR should be plus, but it also has NOT, so you're going to put dash over here, right? Now see, first let's solve this part. A dash plus B dash. A dash plus B dash is A dot B the whole dash. That is A B. Now what you should do? Now this both will break each other. If it breaks each other, it will form A dot B. So this is the output. Which gate has A dot B? That is AND gate. So the answer will be AND gate, because AND has A dot B. So that's how you solve. First look at the input. Here if you see, it's a NOT gate. A dash B dash. Now this looks like OR, sharp end with a bulb. That means it's a NOR gate. So NOR you have to put a big dash, but NOR also has plus, because OR is plus, but it has NOT. So one big dash. If you break this, you get A dot B, which is AND gate. So that's how you solve the question. Second one we will do using the truth table. What is the output Y in following circuit when all three inputs A, B, C are first 0 and then 1? Okay, now they're saying first this A, B, C are 0. That's the first input. Second input will be 1. So let's draw truth table first. A, B, C, Y. Y is the output. We are going to just, okay fine, we are going to just have two inputs, which is 0, 0, 0 and then 1, 1, 1, 1. Now this gate, it's a curved gate. This looks like AND gate, right? See, OR means it should have a sharp one. This has a curved one, so it's a AND gate. So A dot B, and C is connected separately to Q. That means this output and this input, C's input, should be there. So C will be C. Now what is A dot B? Both are zeros, right? First 0, 0 and 0. 0 into 0 is 0 and C is 0. So 0, this is a, which gate is this? This is NAND. AND plus one bulb is there, which is NOT. NOT plus AND is NAND. So A dot B, but AB's output, which is dot to C's. So it will be A dot B dot C. Whatever output I'm getting, it should be opposite because it's a NOT gate. So 0 0 0 into 0 to 0 0 dash is 1. So the output will be 1. We have done. Second one, 1 1 1 1 1 into 1, which is 1, and C is 1, so now into 1, which is 1 dash 0. So this both are the output. So that's how you solve the question, which option has 0, 1, 0, 0. So this is the right answer. So that's how you solve the logic gates. So thank you.